Dear fellow CS70 students, my name is Abraham, and today we will be going over part 3 of week 4 discussion sheet, which is going to be RSA. So, Bob would like to receive messages from Alice via RSA. Part A, he chooses two primes, p equals 7 and q equals 11. What is n? To your right, you can see these two equations. They are your RSA equations. So as we can see, we have A mod n is equivalent to A mod PQ over here and over here. So what does our n have to be? Our n has to be equal to PQ, which means that our n is 77. Part B, he chooses E equals 7. To what number is E relatively prime? Let's see where E is. As you can see, E is up here. And that corresponds to this part of the equation. And because there's also a D up here, we know that ED has to equal to P minus 1 times Q minus 1 times a certain constant K plus 1. This basically implies that ED is congruent to 1 mod P minus 1 Q minus 1. And we know that there is an inverse for E if and only if mod P minus 1 Q minus 1, its mod n is relatively prime to the number. So E has to be relatively prime to P minus 1 Q minus 1. And now we have to find D. I will leave this for you as an exercise, but what this equation basically means is we have to find a certain D such that, we have to find a certain D such that ED is congruent to 1 mod P minus 1 Q minus 1. P minus 1 is 6, Q minus 1 is 10, and E is 7. So this means that 7D is congruent to 1 mod 60. Imagine Alice wants to send Bob the message x equals 30. She applies her encryption E of x to 30. What is the encrypted message x prime? I'll also leave this to you as an exercise. But what you're supposed to do here is that you're supposed to encrypt x. And because our encryption is 7, as we can see above on part B, E is equal to 7, we need 30 to the power of 7 congruent to something. So let's call this Q. Mod, and what should we mod it by? Remember that we need this to be mod PQ, our n. So this has to be mod PQ, okay? Part E. What is the result of Bob applying his decryption function, d of x prime? Do we need to calculate this? No, we don't need to, because we already know that x to the power of ed is congruent to x mod PQ. And therefore, by encrypting and then decrypting it, we will get x. So d of x prime will equal to x, which is going to be equal to 30.